I can write equations using repeated addition to find the total number of objects in arrays. In this lesson, we're going to use repeated addition, which is the same thing as skip counting, to find the total number of objects in something called an array. First thing is, what is an array? An array is any group of objects arranged in rows and columns. So for example, here are some examples of arrays. We have these cupcakes arranged in rows and columns. These bees are arranged in rows and columns. These balls are arranged in rows and columns. These fish are arranged in rows and columns. These airplanes are arranged in rows and one column. These pieces of candy are actually arranged in an array. Here are the rows, and here are the columns. And these donuts are arranged in an array. Here are the rows, and here are the columns. So, what is an array? An array is any group of objects arranged in rows and columns. Organizing objects in an array makes it easy for us to count or get the amount of objects. And we'll see that in our next examples. So let's look at our first problem. Clayton has 3 rows of trading cards. There are 5 cards in each row. How many trading cards does Clayton have? So we're going to use the strategy, make a model, to help us figure out this problem. So of course, the first thing is, what exactly is this problem asking us to solve? So let's look for that question mark. And in the beginning of the sentence, so here is the question. So the question reads, how many trading cards does Clayton have? So we need to figure out how many cards Clayton has. Now, next thing, let's reread the problem and see what information we can use. So Clayton has 3 rows of trading cards. Not 3 trading cards, but 3 rows. That's important. If we continue reading, it also says there are 5 cards in each row. Not that there are 5 cards, but 5 cards in each row. So if we go back and think about what we learned about rows and columns, we will be able to use the strategy, make a model to solve this. So, the word problem says that Clayton has 3 rows of trading cards. So, we could draw the 3 rows first. That would be 1, 2, and 3. So if we draw the rows, this can help as a visual reminder that it's not just 3 cards, but 3 rows of trading cards. Going back to our problem, it says there are 5 cards in each row. So, how many cards would be on this row, the first row? Well, it says 5. So, 1, 2, 3, 4, 5. But not just in one row, in each row. So there are 5 cards in this row. There would be 5 cards in this row. And there would also be 5 cards in this last row. So we're going to go ahead and put that in. Now, we drew everything that the problem said. Notice this is an array. Remember, an array are any objects arranged in rows and columns. And we do this so it's easy for us to find the total amount. Because now we can see that there are 5 here, 5 here, and 5 here. So, to figure out how many trading cards Clayton has, we can simply count by 5s. And that's easy because counting by 5s is easy. So you would have 5, 10, 15. And now we can answer our question. How many trading cards does Clayton have? Well, we just counted it. Clayton has 15 trading cards. Now, let's take a moment and let's just look back at what we drew here. So how many rows did we make with the counters? The answer is 3. 1, 2, and 3 rows. Why did we place 5 counters in each row? Well, the problem stated that there are 5 cards in each row. Why is it important to draw 5 items in each row? Well, Clayton has 5 cards in each row. If we don't draw 5 of these circles in each row, we would get the wrong answer. Now let's take a look at this array. This is an array because it has objects, in this case squares, arranged in rows and columns. So this array has 3 rows of 4. To figure out the total amount in an array, we can use addition because we have these equal groups. There are 4 here, 4 here, and 4 here. So to find the total amount of objects or squares in this array, we can simply do 4 plus 4 plus 4. And that would equal 4, 8, 12. So there are 12 in all. So let's take a look at this array. Why are there 3 4s written as add-ins in this number sentence? Well, each 4 stands for the 4 tiles in each of the rows. So this number sentence is called repeated addition. Why do you think this number sentence is called repeated addition? Well, the number of tiles or squares in each row is equal, so the number 4 repeats. That is why it's called repeated addition, because the add-ins are repeated over and over. That is why it's called repeated addition. Let's take a look at another array. So let's look at this array of red circles. This is an array because the objects are arranged in rows and columns. So how can we describe this array? Well, let's look at the rows. There are 3 rows, and in each row there are 1, 2, 3, 4, 5, 6. So that is exactly how we can describe this array. There are 3 rows of 6. So how many circles in all are there in this array? Well, remember, we can use addition to find the total amount, because in an array we have equal groups. So we have 1, 2, 3, 4, 5, 6. We have 6 plus another 6, because we know it's equal, plus the last row of 6. So we have 6 plus 6 plus 6. And how much would that equal to? Well, if we skip count by 6, if you know how to, then that would be 6, 12, 18. Or if you don't know how to skip count by 6, we can use different strategies, which we learned already, to add number sentences that have 3 add-ins. We could do 6 plus 6, which is a doubles fact. That would be 12, plus the remaining 6. 12 plus 6, we can count on. That would be 12, and 6 would give us the same of 18. So let's look back at what we did. We have 3 6s written as add-ins in the number sentence. Why did we do that? Well, remember, each 6 stands for the 6 circles in each of the 3 rows. This is called a repeated addition sentence. Why do you think that 6 plus 6 plus 6 equals 18 is called repeated addition? Well, remember, the number of circles in each row is equal, which happens to be 6. So the number 6 repeats. That's why it's called repeated addition. In this lesson, you learned how to write equations using repeated addition to find the total number of objects in arrays.